Have you ever wondered how the tiniest strands of hair, the faintest smudges of fingerprints, or drops of blood smaller than a grain of sand can bring justice to criminals? Welcome to the world of forensic science, where crime meets chemistry, biology, and physics, where every clue, no matter how small, tells a story. Today, we're pulling back the curtain on the secrets behind crime scene investigations. And trust me, it's more mind-blowing than you might think. Let's set the stage. Imagine this. A body is discovered in a remote cabin deep in the woods. The victim, a middle-aged man, lies motionless on the floor. There are no obvious signs of struggle, no weapon in sight, and no immediate witnesses. To the untrained eye, it's a mystery wrapped in shadows. But to forensic scientists, this is a canvas waiting to be painted with evidence. The first responders carefully cordon off the area with yellow crime scene tape. Why? To protect the scene from contamination. Every step, every cough, every touch could distort the evidence and jeopardize the case. Forensic investigations begin long before fancy lab equipment comes into play. They start with preserving the integrity of the crime scene. Now, our team of forensic professionals moves in. They're wearing gloves, shoe covers, and full protective gear. Every detail matters at this point. They survey the scene, photographing everything exactly as it is. The body, the position of furniture, even a tipped-over mug in the corner, they all become part of a timeline that reconstructs the sequence of events. Here's the first critical step: trace evidence. What is trace evidence, you ask? It's the microscopic breadcrumbs that connect a suspect to a crime scene, often overlooked by the naked eye but crucial in solving cases. This can include tiny fibers, hairs, skin cells, gunshot residue, or even soil particles, each seemingly insignificant on its own. But when examined closely in a forensic lab, they can reveal vital information about where the crime took place, who was involved, and how it occurred. Trace evidence acts as an invisible link, bridging the gap between the criminal and the crime, helping investigators build a solid case. It could be as subtle as a fiber from a shirt, a speck of soil from a shoe, or a single strand of hair clinging to the victim's sleeve. Using tools like tweezers and vacuums fitted with special filters, forensic techs collect everything. They don't know what will prove crucial yet, so nothing is overlooked. Take the victim's fingernails, for example. If they fought back, could there be DNA, perhaps skin cells, trapped there? One officer collects clippings and seals them in an evidence bag. Standard procedures dictate that every piece of evidence is labeled, logged, and treated with care to avoid cross-contamination. Even a single mix-up can derail an investigation. Once the scene is thoroughly documented, attention shifts to the body itself. Here enters our next forensic specialty: forensic pathology. The medical examiner determines the time and cause of death. Was it poison, a heart attack, or blunt force trauma? In this case, there's something unusual: a slight discoloration around the lips and fingernails. Could this be evidence of cyanide poisoning? To confirm, tissue samples are taken for toxicology. While the body heads to the lab, what about fingerprint evidence? Latent fingerprints are an investigator's best friend. They're invisible to the naked eye, but a goldmine of identifying details. Investigators pull out their secret weapon: fingerprint dusting. Using fine powder, they reveal prints on nearby surfaces. Imagine the suspense when a clear print appears on the doorknob. A quick lift using adhesive tape, and this becomes a critical lead. But modern forensics doesn't stop with fingerprints. Enter DNA analysis, the crown jewel of forensic science. Back in the lab, technicians use techniques such as polymerase chain reaction, PCR for short, to duplicate and study DNA samples from the scene. Remember that hair strand from the carpeting? Its follicle contains genetic material that can link it to a suspect, conclusively proving they were there. At the same time, forensic chemists are hard at work analyzing substances found at the scene. A suspicious powder in a baggie near the cabin is tested using gas chromatography, a method that separates chemicals to identify their composition. The results? It's a potent poison, confirming earlier suspicions of cyanide. But how did it get into the victim's system? This question unravels another layer of intrigue. Forensic toxicologists examine the food and drink recovered from the cabin. The coffee mug, now empty, shows traces of cyanide. Someone intentionally laced the victim's drink. Cyanide is famous for poisoning because it is a highly toxic substance that interferes with the body's ability to use oxygen. When ingested, inhaled, or absorbed, cyanide prevents cells from using oxygen, causing them to suffocate. This leads to rapid organ failure, especially in the heart and brain, and can result in death within minutes if not treated immediately. Its fast-acting and lethal nature makes it notorious in both criminal poisonings and historical events. Still, this doesn't tell us who the killer is. That's where digital forensics enters the picture. Investigators find the victim's phone in his pocket and begin combing through recent calls and messages. The final text sent just hours before the man's death reads, "We need to talk. Cabin at 8 p.m. No one else knows." A footprint at the scene, measured and compared to national footwear databases, confirms a shoe size matching that of a known associate, the victim's business partner. Detectives build a theory. A meeting between the victim and his partner turned deadly. Financial records support the motive, a messy lawsuit worth millions. But this theory needs one final confirmation. The partner is brought in for questioning, and swabs are taken to collect their DNA. The samples are compared to those found at the crime scene. Once again, science delivers clarity. The DNA matches. By now, prosecutors have a compelling case. Intent, opportunity, and evidence linked beyond a reasonable doubt. Let's take a moment to let that sink in. What started as a bewildering crime scene, a body in a cabin with no immediate answers, became a solved mystery because of forensic science. Every breakthrough, from the trace hair fiber to digital text messages, served as a puzzle piece fitting into a larger picture. And the best part? This isn't science fiction. It's what teams of trained professionals do every day to deliver justice. So why does this work matter? Because without science, crimes might remain unsolved, and victims could be denied justice. Forensic science ensures accountability. It strips away lies and deceit, relying solely on facts and evidence. From fingerprints to DNA to digital footprints, it's the bridge between mystery and clarity. Fingerprints are unique to each person and consist of distinct patterns. When found at a crime scene, they can be collected using powders or chemicals. These prints are then compared to a database like AFIS, Automated Fingerprint Identification System, to find a match. If a match is found, it links the suspect to the crime scene. Behind every solved case, there's a team of unsung heroes, the forensic scientists working tirelessly in the shadows. They don't carry badges or chase suspects down dark alleyways, but their contributions are every bit as critical. The next time you see a gripping crime drama on TV or read about the latest high-profile trial, remember this. Real forensic science isn't always quick or glamorous, but it's always meticulous. It's a journey where microscopes replace magnifying glasses and precision reigns supreme. And at the heart of it all is one guiding principle: evidence never lies. Please subscribe for more answers to the unsolved questions, and don't forget to press the like button if you liked the video. If you have a question that you are curious to know its answer, please keep your question in the comment section, and we will answer it in a fully explained video. Thank you for watching the video. See you in the next video.